Welcome to qnawire.
All right, so here we have the function which represents the temperature in degrees Celsius related to the temperature in degrees Fahrenheit as a function of Celsius, and we want to sketch the graph of it. So I'm going to start by finding a couple points that would be on the graph, and then we'll draw a line through them. So if the temperature in degrees Celsius was 0, we would have 9/5 times 0 plus 32, so that would be 32 degrees Fahrenheit. And I'm going to choose a convenient number for C as a second point. I'm going to choose C equals 25 because it's easy to multiply by 9/5. And when we multiply 25 by 9/5, we get 45 plus 32 is 77. Okay, so we can plot these 2 points, 0, 32, and 25, 77, and then we can draw the line through these points. And that represents the relationship between the two temperature scales. In part B, we want to talk about the slope. So what's the slope and what does it represent? When you look at the equation, you can see that the slope is 9/5. And if you think about the units on slope, the slope is change in y over change in x. So the units on y were degrees Fahrenheit, and the units on x, or C in this case, were degrees Celsius. And so the slope is showing you the change in degrees Fahrenheit for a change in degrees Celsius. So it's telling us that it would go up 9 degrees Fahrenheit for every 5 degrees it goes up Celsius. So it goes up 9 degrees Fahrenheit for every 5 degrees Celsius rise. Now, how about the y-intercept? Or in this case, we'll call it the f-intercept, since our y-axis is known as the f-axis in this problem. So the point where the graph intersects the y-axis is the point 0, 32. And that would be the point where it is 0 degrees Celsius. So when it's 0 degrees Celsius, it's 32 degrees Fahrenheit. When it is 0 degrees Celsius, it is 32 degrees Fahrenheit. And we think of that as the temperature of freezing for water. That's water's freezing temperature.